Today we are going to be evaluating a single trig function for special angles. So the first step is going to be to graph the given angle, whether it's radians. We want to start by graphing it. Then we are going to connect that angle to the origin, which it already really will be because that's part of graphing an angle, and then also connect it to the x-axis. Always the x-axis. Cannot emphasize that enough. We always connect to the x-axis. Then we're going to find that reference angle. Yesterday we talked about reference angles as being next to the origin, acute, and always positive. That reference angle must be, today, for these types of questions, 30, 60, or 45, because those are special angles for us. So if you get something different for this type of question, you subtracted wrong. So try again. So we're going to label the sides of those special triangles. So I warned you yesterday it would be helpful if you were familiar with those special triangle patterns. So we'll review those today. And then we're going to do SOHCAHTOA for our trig function. Today's questions are going to ask for just a single one. So we don't have to list all 6. We can just do whichever one it says to do. So, first example, evaluate tangent of negative 210. So we begin, step 1, graph the angle. We start at the positive x-axis. A negative angle, we go around clockwise. Where will 210 land clockwise? 30 up above the 180 since we're going in a clockwise direction. So our reference angle is that 30. We connect to the x-axis to enclose that 30-degree reference angle. The sides of the 30, 60, 90 are 1, 2, square root of 3, always the same pattern. 1, 2, square root of 3. Make sure that as you are doing this, you remember that 2 is the hypotenuse, and square root of 3 is the longer perpendicular. Students always mix those up because we just kind of feel like a hypotenuse should be more messy than a side, which is not true. But we kind of feel that way. You can remember that 2 is bigger than the square root of 3. And remember we learned in geometry that across from the biggest angle should be a biggest side. So that hypotenuse has to be the biggest number, which is 2. Okay? So remember that 2 is the hypotenuse and the longer of the perpendiculars is the square root of 3. Across from the 30 goes a 1. Then it is possible that we have some sides that need to be negative. Yesterday we talked about sides of triangles being negative, meaning a direction of them, not necessarily a negative length, but a negative direction. We said our hypotenuse will always be positive no matter what direction it looks like it's going, but the perpendiculars could be negative. The 1 in this problem will be positive because it's vertically upward, but that square root of 3 is going to be negative because horizontally it is to the left of the origin, and that's where our negative x-axis is. So since it's over on the negative portion of the x-axis, that's going to be a negative value. The 1, though, is vertically upward, so it will be a positive value. So now we have everything labeled in our diagram. So now we need to consider SOHCAHTOA. So in this question, we are looking at tangent. What is, my screen isn't letting me grab. What is SOHCAHTOA for tangent? SOHCAHTOA for tangent? I heard some right answers, I heard some wrong answers. Opposite over adjacent. See. This is inconvenient. Okay. Struggling. Okay, opposite over adjacent. So in our triangle, what was opposite of that reference angle? 1. And what is adjacent to that reference angle? negative square root of 3. We're always focusing on that inner angle by the origin for our reference angle. Okay. We're going to leave square roots on the bottom of fractions. And that goes for all of your homework questions. So even the stuff that we talked about yesterday, while you're doing those questions, you may end up with square roots in the denominator. We're going to leave them there. Simplify them if possible. Okay, break them down and simplify them. Reduce fractions where possible, but leave square roots on the bottom. The next question says cosecant of 11 pi over 4. So we're going to begin by graphing this. Yesterday we talked about graphing in radians, that we cut each half of the circle into the denominator number of pieces. Then we begin this, just like and the numerator tells us how many pieces to go. So we're going to go around 11 pieces. Pieces will take us all the way around. 9, 10, 11 will take us 3 more. So that we end halfway through that upper left-hand quadrant, the second quadrant. Close down to the x-axis. Always close to the x-axis. How big will our reference angle be? 45. Because 180 divided by 4 is 45. So each of those slices has a size of 45. Sides of the 45, 45, 90 triangle are 1, 1, and square root of 2. In the 45, 45, 90, always both perpendiculars are 1, and the hypotenuse is square root of 2. The hypotenuse will always be positive no matter what direction it looks like it's going, but the perpendiculars we need to consider might be negative. Are either one of these negative, and if so, which one? The horizontal one is negative because it's on the left of the origin. The vertical one is going up from the origin, so it's still positive. So then we want to calculate cosecant. Cosecant doesn't have a SOHCAHTOA, but what is cosecant the reciprocal of? Sine. And what's the reciprocal for sine? Opposite over hypotenuse. So we're going to be working with then hypotenuse over opposite. So what's the hypotenuse in our triangle? Square root of 2. What is opposite of our reference angle? The positive 1. So we get square root of 2 over positive 1, or just square root of 2. If you left it at square root of 2 over 1, I would accept that answer. Cosine of negative 150. We begin by graphing our angle. Positive x-axis. Go around backwards. So we're going clockwise 150. Where does that land? 30 short of the 180. Close up to the x-axis. Always to the x-axis. Label the side. Across from the 30 goes 1. Hypotenuse 2. Across from the 60, or the longer perpendicular, is the square root of 3. Hypotenuse will be positive. What about the others? Negative 1 and negative root 3. They are both negative. The negative root 3 is on the left of the x-axis, and that negative 1 is going downward from the origin. So when we're graphing lower half verticals, they will be negative, and left half horizontals will be negative.
Why wouldn't 2 be negative?
Hypotenuse is always positive. So our triangle is labeled, so then we need to think about our trig. So what is SOHCAHTOA for cosine? Adjacent over hypotenuse. What is adjacent to our reference angle? Negative square root of 3. And what is the hypotenuse? 2. So we get negative square root of 3 over 2. (16 pi over 3), we are graphing in radians. I said something yesterday about graphing pi thirds that we have to do a little bit differently. What's different with thirds? Get rid of the vertical, because when I break each half into 3 pieces, vertical does not help with that. So when we're graphing in thirds, we want to ignore the vertical axis because that does not help us make 3 equal pieces. Then we need to go around 16 pieces. Around once covers 6. Around twice covers 12, 13, 14, 15, 16. You do not have to draw your spirals if you don't want to. It doesn't really matter how many times we went around in the end. It just really matters where we ended. So if you don't want to draw your spirals, you don't have to. How big is that reference angle going to be? 60 degrees, because 180 divided by 3 is 60. In our 30, 60, 90, across from the hypotenuse 2, and across from the 60 is the square root of 3. Anything need to be negative here? If so, what? The 1. Anything else? And the square root of 3. They both do. Left and down needs to be negative. We don't have a secatole for cotangent. Cotangent is the reciprocal of tangent, which is adjacent. So flip that over and we get adjacent over opposite. What is adjacent to our reference angle? -1. What's opposite? Negative square root of 3. Negative over negative. We can cancel the double negative and get 1 over square root of 3, but leave your square root on the bottom.
Wait, are you sure you're... Wait, okay, never mind.
The other two I don't have slides for, so we'll just do those on a blank board. The first one we'll do is the secant of 135. So we'll graph that. Where's 135 going to land? $45 above the 180. 180 minus 135 is 45. Sides of the 45, 45, 90 are 1, 1, and square root of 2. So anything need to be negative here? The bottom one, the horizontal one, is left, so it needs to be negative. The vertical one is up, so that's positive. Secant. We don't have SOHCAHTOA for secant. Secant is the reciprocal of cosine, which is adjacent over hypotenuse, so we flip that over and do hypotenuse over adjacent. What's the hypotenuse? Square root of 2. What's the adjacent?
1.
The negative 1 is the adjacent. Dividing by -1, I get negative square root of 2. Nice, so simplify when possible, but leave square roots on the bottom if that's where they are. And the last example is the sine of -5 pi over 6. So begin with a graph. For radians, we do the denominator number of pieces in each half. Begin at the positive x-axis, go around numerator number of pieces, so -5 pieces. And how big is that reference angle? How big is each slice? 30. 180 divided by 6 is 30. Label the sides 1, 2, and square root 3. Anything need to be negative? If so, what?
1 and square root.
They both do. We have a downward side and a left side. What's SOHCAHTOA for sine? Opposite of a hypotenuse. What's opposite of the 30? Negative 1, and hypotenuse?
2.
Positive 2. So we get negative a half. Okay? Your homework is from 13.